So yesterday we have discussed earlier that is creating a new array list, which is a collection. What are we doing is we are adding three student objects, student 1, student 2, and then student 3 to the array list, and then you are printing this in. Now, to the array list, you can add duplicate values. Array list, you can add duplicate values. It is an index, and it is an index that is based on the index. You can add the value at any location by specifying the index, as well as you can remove the value by specifying the index. Now next what we have got is we have got hash set. So hash set, it extends from your set interface, and just hold on for a minute. Now so this topic is completely based on this diagram. So then next you have got set. Set, it has got two implementation. One is hash set and next one is the sorted set. So when you're adding the elements to the set, it is not an index collection. This one, it is an index collection, but this is not an index collection. The elements are added to the set based on the hashing algorithm. And then again, you've got the sorted set. If you want the elements to be always present in the sorted order, then you can go with the tree set. So that is the basic difference. Let me just go through that. We completed up to array list. Now, it contains unique elements. Duplicates will not be added. It has got no index. Duplicate elements are not allowed. You can iterate through the element and treats that it provides the sorted implementation. So, instead of using list, let me use set. Rest of the stuff will remain the same. Right click and then say run file. So if you see it's like 104 you're getting 101 and then 103. You will not get the elements in the same order. You add it one way, you will get it in the another way. Clear with this? It is based on the hashing algorithm. Now if you say tree set, then the elements will always be there in the natural ordering of the elements. Okay, you need to write some code for this. Let me just change this to hash and I'll show you how to write the code. Let's say I'm creating a class called alphabets. Set of alphabets is equal to new tree set. First I'm adding zebra. So you added the zebra, tiger, and then apple. But when you are printing the elements, it is apple, tiger, and then zebra. So when it comes to the tree set elements, by default they are sorted on the natural ordering of their elements. Clear on this? If it is alphabets, it is A, B, C, D, and if it is numeric, it will be 1, 2, 3. So if you want the elements that are being added to the set to be sorted based on the natural ordering of their elements, then you can go with the tree set. Is it clear? Okay, fine. So if you want all the time to be elements present in the sorted order, then you should go with the sorted set. Over here it has got the penalty that each time an element is being added, it has to sort and then add it. So you should be very much careful when using this. Okay, so this is done, set interface. Now next what we have is map interface. A collection that stores multiple key and then the value base. And then key and then you have got value unique identifier for each element. That is key is 101 and its value is blue shirt. Key is 102, its value is black shirt. Key is 103 and value is gray shirt. So it is a collection that stores key and then the value pair. This is key and this is value. It is also called as in two-dimensional arrays in other languages. Now, map is a collection, but it is not part of the collection interface. The method what we have in map is quite different from the collection hierarchy. There we have got the methods called get, and in order to add the element, we have got method called add. But over here, in order to add the element, we have got put, and in order to retrieve the elements, you have got method called get. Over here, you will retrieve the element based on the key, or you'll retrieve the elements based on the key. In the list, we retrieve the element based on the index, but whereas in this map, we retrieve the element based on the key. Again, map is classified into three different. One is sorted map, the other one is hash table, the other one is hash map. When it comes to the sorted map, it is an interface entry map provides the implementation for the sorted map. As the name itself it indicates it is sorted. The map by default is sorted. So the moment we are adding the elements to the map, it is sorted based on the natural ordering of the key element, not based on the value. It is sorted based on the key. And in hash table, you have got properties. Hash table, again, it is key and then the value pair. In the hash table, you can store key and the value pair. Values can be null. It permits null values, whereas hash map does not permit null values. The difference between the hash table and the hash map is hash table permits null values and the methods are not synchronized, whereas hash map it allows null values and it does not allow null values and it is synchronized. And then you have got properties. Over here, that key and the value, it has to be string. See this one, tree map, hash table with key and values. Hash table, it's synchronized and it does not accept key values. Over here it can accept null values and it is not synchronized. This is the difference between the hash table and hash map. Now let us go with an implementation. So let's say okay, I'm having questions. Public static void main map question map is equal to new hash map. So let me do string and then string. Question map dot put. Let's say Q1 is what is Java? Question map dot put. Q2 is what is C? Some XYZ questions. This is how you create your map. And if you want to print it, system.out.println of question. Right click and then run file. So it is printing the complete map, question map, what is Java and what is C. Now let's say if I want you provide the key and it should return you the value. That is if I provide Q1 it should return me what is Java question map dot get Q1. You provide the key it should return you the value. So I'm providing the key, it is returning me the value. So if I say Q1 it should return what is Java, and if I provide Q2 it should return me what is C. Clear on this? Then I want to retrieve only values. So if I want to retrieve only values, I should make use of collection. So question underscore map dot values. It is returning you collection of strings. questions. Import the required package. Once you are done, system.out.println of questions. So what is Java and then what is C? Let me just comment this. Format. Now if I run it one more time, so it is returning you only the questions. So if you invoke values method on the map interface, it will return you the values. Now let's see if I want only keys. It is string keys. Key set. System.out.println of keys. So it will return you Q1 and then Q2. Is this clear? Okay, fine. So you have got over your question, ID, question number, image path, and then this. For this you need to create this. Map question ID should be mapped to the question. Question ID, it should be mapped to the question. This one for this created. Question ID should be mapped to question. Now, let's say I want to sort this. First we are writing Q3 and then I'm writing Q1. So I want to sort these questions. So how do I sort? We are having the map, or I want to sort the collections. How do I sort it? Now let's say I'll go back to the students and this one. Okay, fine. This class we have. So if you are if you are running this, it it is printing you 104, 120 and something else. 101, 104 and 103, I guess. So I want to sort them. That is, I want to print them in order. So how do I do that? Any idea? Okay, I'll just give you a hint. Now over here, you're having these are the various desktop items that are available. Now I say right click and then say sort by. So what I'm doing, so your desktop item had got name, they have got size, what is the type of the item, and then the date modified. So actually all these desktop items, they are objects. So when you want to sort them, you have to specify the property by which you want to sort. It cannot sort by itself. By default, it does not sort by itself. You need to specify the property by which it should sort. Over here, if you say name, it will sort it based on alphabetical order, size, and then you have the type and then the date modified. So you specify the property based on that it will sort it. Is it clear? If you want to sort the objects, you have to specify the property based on which it should sort. So over here we will create a class called list of items. Now this desktop items, okay, have got the three properties. Uh, it has got name, type, size, date modified. Okay, so private string by name, private string type, and then private integer size. Provide a constructor and provide toString. I will make it public so that you can access. Format. Now, if you want to sort the items, if you want to sort these items, then you should implement an interface called comparable. If you want to sort the objects, you should implement the interface called comparable. So if you want to sort the desktop objects, so you need to implement an interface called comparable. This comparable, it is a typed interface, that is, you should provide the class name for which the class name which you want to sort the objects. You need to specify the name of the class which should be sorted, whose object should be sorted. So we want to sort the objects of the desktop item class. So that is what we are passing as an argument to the comparable interface. So this comparable interface, it has got a method called compare to. The comparable interface, it has got a method called compare to. So over here you will be writing the sorting logic. Now, how this works is, this compare to methods, it returns three values: 0, 1, and then -1. If it is returning 0, it means objects are equal. If it is 1, the object is greater. If it is returning -1, the object is smaller. Now first understand that with the help of an example. String A. This is str1. This is str2. So this also I'll write it as A. Now integer difference is equal to str1 dot compared to, this is already written, string 2, and then I'll be writing system.out.println difference is equal to plus difference. Now let us execute and check the output. Now if it is returning 0, it means A is equal to A. So internally what it does is it compares both the string based on their ASCII values. That is, it is tried to, what it does, it's the ASCII value for A is 65 and ASCII value for B is again 65. It does 65 minus 65 and if it is equal to 0, then both the strings are equal. Now change the value for this, make it B. ASCII value for B is 66. So 65 minus 66 is minus 1. So B is greater than A. Clear with this? So sorry, minus 1 is B is minus 1 if it is returning, then it means A should come first, then B should come. Is it clear with this? Do you have any doubts? Is this logic clear? Because we are going to use the same logic. Okay, so now let us proceed. Now over here, the same thing what we are going to do. Integer difference is equal to d2. So size minus d2 dot size. If size is equal to 0, then return 0. Else check if size is greater than 1. If it is greater than 0. If it is greater than 0, it should return 1. Otherwise, it should return minus 1. This is how it works. If it is equal to 0, it means they are equal. If it is greater than 0, means object is greater. Otherwise, object is small. So these are the three cases that are possible. So you have written this equals method. Now let us create a test class, public static void main. So over here, create a tree set. Now this set will contain only your desktop items. New tree set. Import it. Add the items. The items dot add. So new desktop item. So wait 1 minute. Let me create it. D1. So string name. Let's say HTML doc. And then type is dot doc. Size is 100 KB. Items d2 is equal to a new desktop item, and this one is, let's say, some notepad stuff. Type is text. Size is 10 KB. Let me create one more. D3 is equal to list of items, mm, image, JPEG, size 1 MB. This is how it works. So after that you are adding each item. D1, D2, D3. So you're adding these three items. So when you're adding these three items, it will be sorted. Before the items are added, it is going to be sorted. Now if you observe this, over here you have specified the sorting order based on its size. Over here, if I expand this, the sorting order is based on the size. You're sorting the elements based on the size. So you should receive 10, 100, and then 102. Right click and then say let's run 5. Oh sorry, I did not print it. Let me print it. Let me loop. So let me loop it. So oof. Hold on for a second. It did not sort. Mm. This should be sorted. Mhm. This is difference. So it is 10, 100 and then 1024. This is how the elements are sorted. I missed over here. So this should be difference. Clear on this? Is there any doubt? Is it clear? The difference is between the size. It will compare this one. 100 minus 10. First element is 100. 100 minus 10, that will give you 90. So if it is equal to 0, it returns 0. Otherwise, if difference is greater than 1, it will return 1. If it is returning 1, then you will get this one again. Then if it is returning 1, then what it does is it will rearrange. First 10 will be there and then 100. It is not a keyword, it is a logic what we are writing. It is used for rearranging the elements. Over here. And this is based on this logic. That is the reason we have discussed this. String A and then B. It will subtract this from this. Compared to method, basically it will do the subtraction. Logic based on your requirement you can try. But the standard is to subtract. So over here under this desktop items, you are enter 100. First element is 100. First element that is added this one 100. So that is the first element. Then when you are adding the next element, what it does it will subtract this minus this. The existing element 100 minus whatever element you are adding. So 100 minus 10 will give you 90. 100 minus 10 will give you 90. So if it is 90, it returns this one. Difference is greater than 0. If difference is greater than 0, it returns 1. So it means this object should come first. First 10 should be there, then 100. So it will rearrange. Oh, so first you will get 10. 10 text and then notepad, and then it will place this object at the end. So then 100 doc, and then you have got HTML doc. Now when you are adding this third element, its size is again 1024. So when its size is 1024, so obviously it is going to be greater than what is the existing stuff. So it tries to subtract 1024 minus this. So and it returns and it adds the elements to the end. This is how it works. 10, 100 and 1024. Each time you are adding the element to the set internally, it will invoke the toCompare method to place the elements in the correct order. Is it clear now? Okay, fine. The next what we have is comparative. Now over here what you see is, let's say if I want to sort it by name, I can add sort HTML, dog, or this. You have got three attributes. So you can sort it based on any of the attributes. So you can either sort by name, or you can sort by type, or you can sort it by size. Over here we are sorting it by size. But what if I want to sort by name, or what if I want to sort by type? That is, I want to give the option to the user at the runtime to select the option based on which he or she wants to sort the elements. But over here, if you observe, the sorting logic is embedded within the class itself. So over here, it is embedded within the class, that is, we have fixed it. That is mandatory, that is by default, it will sort it based on size. You are not providing any option to the user to select the property or to select the column based on which he or she wants to sort. Over here, the sorting logic is fixed. That is by default, all the elements added to the set are sorted based on the size. But I don't want this. I want to make it dynamic. I want the user to enter the column based on which he wants to sort. So this way I want. You should provide the option to the user. So whether you want to sort by name or type, or you want the user to sort by size. So what we have to do is, rather than writing only one sorting logic, you need to write multiple sorting logic or multiple options. So first you will write the logic to sort by size, then you will write the logic to sort by name, then you will write the logic to sort by type. This is how it works. Now, what do we do is, it is quite simple. Let me just copy this code. Desktop items, right? So I'll create one more class called desktop item 2. Let me paste this code. Okay. Now instead of this comparable, we don't require this. Now let me create a simple class. So this is your desktop items 1. Now for this, you want to provide 3 sorting logics. One is by name, type, and then size. So if you want to provide different sorting logics, you need to write a separate class for each. So if I want to provide 3 sorting logics, so how do I do is, class, okay, sorry,
name. You want to sort it based on name. Name sort. You need to implement an interface called comparator. Now what you want to sort? You want to sort the desktop items. 1. Now similar to compare to method, this class has got a method called compare. So as usual, I'll just say D1 and D2. Now if you want to sort by name, return D1 dot name dot compare D2 dot D2 dot name. That's it. Now let's say you want to provide the sorting logic. You want to provide the sorting logic for size. Size. You want to sort the elements based on the size. We are writing one more class that implements comparator interface. Implement all the abstract methods. And the sorting logic for the size we have already written in the previous demo. Let me copy and paste that. D1.size. So this is D1, this is D2. So this is one we are providing based on the size, and then again you want to sort based on type. Type sort implements desktop implements. D1, and then again I'll write it as D2. Return D1 dot type dot compare to D2 dot type. This is how you do. View full screen. So this is the desktop item class what you've written. If you see, okay, you're providing 3 sorting methods, one for name, other for type, and the other for size. So if you want to provide multiple sorting options for a given object, then you need to implement an interface called comparator. This interface comparator, it has got compare method, wherein you will write the sorting logic. So sorting logic is inbuilt for the string. You just need to call compare to method to compare both the string d1.name and d2.name. When you're calling, it will compare the strings based on their ASCII value, that is based on this. It will subtract string 1 from string 2, based on which it will arrange the elements. Then next what you have is, you are sorting it based on the size, you are subtracting it. If it is returning 0, elements are equal. If it is greater than 0, element is greater, otherwise element is smaller. And then next logic what you have is type sort. The same stuff you're doing, d1.type compared to d2.type. Now let us test the class. As usual, let me copy this and then add this. You are testing the method. Now for the first time, let's say the stop items 1. Let me change this 1, 1. So done. So let's say I want to sort it by size. So I should say, I should pass the reference of this comparative, sorted based on the size. So this time you're going to get 10, 100 and 124. 10, 100 and 124. Next I'll do sorted based on name sort. So first H, I, and then N. If I say sorted based on type, so first doc, D, J, and then T. Clear with this? Is this clear? So you have got two things. One is comparable, the other one is comparator. Comparable, you will have only one sorting technique, and comparator, you can provide more than one. Any doubts? So with this we have completed the collections and we are left with the threading. And after threading, okay, we'll start with either Hibernate or JS. So I request you to practice this stuff. And if you have any doubts, just let me know. So we'll wind up the session for today.